Hello, I'm Ben Glass, CEO and CTO of Alteros, and I'm excited to share a little bit about our approach to connecting the unconnected, as well as introducing you to super towers and the concept of aerial cell towers. Now, in addition to introducing you to Alteros over the next 30 minutes, I really want to answer four key questions. First, why is rural connectivity so difficult? Why do we still see such a huge digital divide? Second, how do aerial cell towers help expand rural opportunities? Third, why aren't we already using aerostats or aerial cell towers? And finally, how do super towers fit into the broader set of rural broadband solutions, given the magnitude of the challenges so great? We really need a large number of potential solutions. So, a quick introduction to Alteros. I wanted to share our mission, which is really to connect people, machines, and data anywhere in the world that they happen to be located, which really means that we're very focused on the challenge of rural connectivity, the challenge of providing modern connectivity in the markets, in the areas that traditionally are underserved by infrastructure today. And so we'll talk a lot about our approach to rural connectivity. I also wanted to just give a quick brief or a quick explainer on aerostats. It's a technology that, despite being around for many decades, a lot of people are not familiar with, haven't run across aerostats before. But essentially, they're tethered blimps, which serve as a high capacity, long endurance aerial platform. And unlike a lot of the aerial platforms or drones that we're used to seeing, aerostats can lift, hundreds of kilograms, hundreds to thousands of meters above ground for very long periods of time. And you can see here on the left, one of the aerostats that we build at Alteros. You can see at the top of the image is the helium-filled envelope. This provides the lift. Below that, right at the belly of the envelope, you can see the payload and avionics bay, where obviously the equipment that's really doing the job you're there to do is located. And all of that is connected to the mooring station on the ground via, in our case, 3 tethers. And one of those tethers, the umbilical tether, has embedded power conductors and optical fiber to transmit data and power to the airborne equipment and down. And finally, on the mooring station, we've got a number of winches that control the tethers to control the altitude, to reel the aerostat in and out, and control the system. So the first question, why is rural connectivity so difficult? Why haven't we solved this problem? And like many things, it really comes down to economics. And we can compare rural markets with urban. If you look at an urban market, much higher, very high population density, tends to be relatively wealthy areas. And if you look at that and look at the potential revenue from the perspective of a carrier, a carrier can literally earn hundreds of thousands of dollars per square kilometer in some of the dense urban centers. By contrast, rural markets are characterized by very low population densities spread out over a large area, and more often than not, a relatively less wealthy population. And so combined, you get a revenue potential that's orders of magnitude lower than an urban center. So the challenge is really how do we provide the same level of service, the same user experience that an urban customer takes for granted, but in a rural market where the revenue potential is so much lower, and you have to provide that coverage over such a large area. So that really, I think, is the fundamental challenge of how to provide rural connectivity and what we need to do to overcome the digital divide. So let's start by looking at the economics of how rural infrastructure is built today. So typically we see towers that are 40 to 60 meters tall. They provide 10 to 15 kilometers of coverage. So overall, you get 300 to 700 square kilometers of service from each tower. If we look at the economics from the perspective of the carrier. There's obviously the CapEx to set up the site, to bring in the RAN equipment, to bring in the backhaul, and then the annual OpEx to keep the site running. So this is the tower rent, keeping your equipment up and running, obviously lighting up your backhaul, and power, other miscellaneous charges. Obviously, this depends very much on where in the world you are, the specifics of the site. But roughly speaking, if you take the net present value of sort of the lifetime cost of building and running a tower site, you're looking at about $600,000, which gives you an approximate cost. Order of magnitude is about $1,000 per square kilometer of coverage in a rural market. The challenge, though, is you have to build a lot of towers because rural markets are very large, very spread out, and you need to provide, the goal is to provide coverage over the entire market. So you're going to multiply that single tower cost by a large number of towers. So if we compare that with the economics of building rural infrastructure with aerial cell towers, we can look at a typical super tower will operate around 250 meters up to 300 meters high, and you can get a coverage radius of 40 to 60 kilometers. So you're covering a much larger area, typically up to 10,000 square kilometers, which is equivalent of the equivalent of up to about 16 of the individual 40 to 60 meter towers. So if we look at the comparison of the economics, you still have all of the same components of economics, but you end up realizing that the cost is significantly lower if you can deploy one aerial cell tower, one super tower, instead of 10, 12, up to 16 regular towers. So when you run the numbers, you see the cost of building and running that rural network comes out to about half of what you would see with traditional towers if you're able to use aerial cell towers to reduce the number of sites and consolidate that infrastructure into a fewer number of sites. And you look at the breakdown, it's about a 90% lower CapEx and 30% lower OpEx. To run that, a lot of the OpEx savings are in fact coming from power, which is particularly challenging in a lot of rural markets in developing countries where they're dependent on diesel generators. But it's really not just the economics. It's important that we are considering the user experience. And it used to be okay to just provide essentially basic voice, basic text services, but that's really not good enough today. The use of connectivity, the use of broadband really extends way beyond just simple voice and text, and is important for almost every aspect of modern life, whether it's education, entertainment, even business and medicine are increasingly done via the internet. And these days with the COVID pandemic, that's really shown a spotlight on the challenges in rural markets where there isn't modern connectivity is really driving that digital divide even wider than before the pandemic. So this is really important. And if you talk to carriers in a lot of urban markets, I was talking with an executive at a carrier in Southeast Asia, and they're talking about how they would go into a remote village and put up a tower and provide basic service, but as soon as that service comes online, because connectivity is used for all of these other elements, the demand for data just skyrockets, and almost overnight that tower is overwhelmed. So it's really important as we're thinking about solutions to provide that complete online experience that we're building really future-proof solutions that can handle this explosive demand in data. And that's really what we focused on with one of the super towers that we built, the ST300, which is really targeted towards providing very high capacity service in rural markets so that we can provide the same user experience that we take for granted in urban centers. So you can see a little bit on the ST300 here. It carries 300 kilograms of telecom equipment, again, up to a maximum height of a little over 300 meters. The site architecture is very much like a traditional site where you've got your radios and antennas up in the airborne payload bay. You've got your baseband unit, your backhaul equipment on the ground and connected via the optical fiber in the tether. And the fact that the architecture looks just like a regular tower allows it to be very seamlessly integrated into existing networks. And I'll talk a little bit about that in a few minutes. But again, having this very large payload mass, large amount of power, allows the ST300 to work with really almost any type of RAN equipment from any vendor. And so we really try to provide a solution that is vendor agnostic, equipment agnostic, technology agnostic, but provides enough capacity to really deliver a high level of throughput in a very reliable, cost-effective manner. So maybe just a little bit on some of the performance of these larger permanent super towers. So this is a trial that we ran with a tier 1 global carrier, PCS band, and the goal was really to evaluate the performance of the super tower as it was integrated into an existing LTE network. And we ran this at our facility in New Hampshire, where it's I would say it's a sort of a dense rural area. So there's quite a few towers around, and we were really looking at the inter and intra-site handovers and overall KPIs for both the super tower site and the network as a whole. And what we found is that, again, because the equipment that we were running, so we were using Ericsson radios for the RAN equipment, and because it's something that the carrier was very familiar with, was already using in their network, we were able to very quickly and seamlessly integrate the super tower into the existing network. And over a 30-day period that we were running this trial, we saw really excellent KPIs. I mean, meeting all of the expectations for the network, and I think really critically, the handover performance really exceeded our expectations and met the requirements for a high performance network. You can see the intra-frequency handovers were up 98, 99%, inter-frequency essentially 100%. So very high performance for the network. And this was running hundreds of thousands of daily connections. Again, it was rural, but not that rural of an area. We were seeing individual throughputs on user devices, just standard cell phones, of 100 megabit per second downloads, 60 megabit per second uploads, very low latency. And critically, we were able to leverage a lot of the features of the radio equipment in particular, to use the self-organizing network to easily manage the dynamic neighbor list as the super tower moved around. So overall, I think we're very, very happy with the performance, and I think demonstrated the ability to use this type of solution in an existing network. But those large permanent installations and applications aren't the only use case for aerial cell towers and super towers, especially when we see the potential for a rapid response aerial cell tower for things like emergency response. If you have a hurricane or a natural disaster that takes out the existing network equipment, you need to come in and restore service, both for subscribers and first responders as quickly as possible. If you're looking to expand the edge of your network and you want to do so quickly in front of the permanent infrastructure build out, that's a great opportunity for a rapid response aerial cell tower, as well as just temporary communities, temporary events, as well as a lot of remote industrial activities where these types of systems can be a really powerful tool. And so, we actually just announced a new product, the ST Flex, which we've designed to be very easy to deploy, very quick, set up in less than a day, easy to tow either on highway or off road. This is, it's a little bit smaller than the ST300, but we can carry up to 60 kilograms of payload. Provide a kilowatt of power to that payload. So again, it has a lot of flexibility to incorporate a wide range of payload options, whether it's LTE, 5G, Wi-Fi, various IoT protocols, to provide the maximum amount of flexibility for customers in these emergency or other rapid response scenarios. So now that I've introduced aerial cell towers and aerostats and super towers, we have to ask the question, why don't we see these more? I mean, aerostats are a technology that have been around for decades. They've been used extensively by the U.S. military, by militaries around the world, and yet we really don't see them in widespread adoption in telecom or other commercial applications. And like many things, it really comes down to economics. So traditional military aerostats are just too expensive for commercial applications. And the main driver for this high cost of operating the traditional aerostats is the very large crew that they need to maintain. So you can see a picture of a U.S. Army aerostat on the left, and you see a bunch of folks up there on the platform. You can see one guy here with his hand on a joystick, a bunch of folks here down by the tethers. Those people aren't just standing there. They're actually, working and operating the aerostat, which is surprisingly manually intensive to do it. And so in order to operate a typical aerostat, you're going to require a crew of between 4 and 10 trained personnel on site 24/7 to keep the system operating. And that really drives up the cost of running a traditional, again, military aerostat or traditional aerostat. And so that's really where we focused at Altaris. We have taken that kind of core aerostat platform, which has a long track record of successful deployments in military applications, and brought in modern control, modern automation to the design, which has allowed us to eliminate the need for any crew for day-to-day operations, allows complete remote monitoring and remote control as needed, brings in levels of autonomous, we call it Aerostat Autopilot, is sort of the suite of autonomy software that we've developed. And again, this allows us to significantly reduce the cost up to 80% lower cost to deploy an autonomous aerostat versus a traditional aerostat, which really makes the economics effective and viable for commercial applications and a much wider range of commercial applications. In addition, that automation, that control actually improves the reliability of the platform, the mission availability, reduces the wear and tear on the system, because we can control and react to weather and other environmental factors in real time. So we really think that automation is the key to unlocking aerostats as a critical part of the solution for rural connectivity and for connecting the unconnected. So here you can see a video of one of our aerostat systems. You can see some of the elements of the autonomous operation. for folks who are less familiar with aerostats, it may seem pretty simple, but to see a system like that, launch and land and operate autonomously is really a pretty significant leap forward in the state of aerostat technology. And I think for folks who are very familiar with aerostats, it's always very exciting for them to see this type of innovation. So, as I mentioned, the challenge that we have ahead of us is enormous, and it's going to take a huge number of different solutions to really provide affordable connectivity to the half of the population that's unconnected today. And our goal is to be a tool in that war chest to really provide a great solution for at least some of those opportunities to bring people online for the first time. I think the areas that we're really focused on trying to contribute is in reducing the cost of providing that last mile connectivity in rural markets, trying to reduce the dollars per square kilometer as much as possible. And the goal is to leverage that step change in economics to really try to expand access and provide more opportunities in these rural markets that have historically been left behind because the infrastructure solutions are not designed for their unique challenges, are not geared towards them. And if we can reduce the cost of rural infrastructure enough to shift rural markets from a loss maker to really a profitable enterprise for the carriers, I think that's the catalyst that we need to really accelerate the build outs, accelerate the deployments to bridge the digital divide. And then finally, I think there's a lot of really important opportunities as we look at increasing frequency of natural disasters, where connectivity is such a critical tool for the first responders as well as for the people impacted by those emergencies. We think that there's a huge opportunity to bring the ST Flex rapid deployment super tower to help in those scenarios. And I think I'd be remiss if I don't mention sort of how I think there's a real complementary element between super towers and aerial cell towers as a great last mile solution with some of the upcoming low Earth orbit satellites that are going to solve some of the biggest backhaul challenges in many of these markets. So that combination of LEO satellites as a critical, high performance, low latency backhaul link with super towers and aerial cell towers as that last mile solution, providing the connection directly to the user handset, I think is a really powerful combination as we look to combat the digital divide. And that is all I had to share. Look forward to a very productive discussion, and hopefully we can all work together to overcome some of these challenges. Thank you very much.